We have a basic mixing problems one. Oh, draw a picture of 42069. That'd be an interesting drawing. I'm trying to think of the logistics of that. like two. It's Twitch, so I do two like stick figures who might happen. One might happen to be the reverse direction of the other for no particular reason, and then there need to be some joints too. But the solution also refers to the solution associated with the initial datum. Really? Huh, I never heard that, but maybe. It's, 5 minutes, I think. If you try to redeem it, it should tell you like a countdown too. Here's the answer. Using 9 times 111. Ones would just be the 9, yep. Tens place is 7 plus 9 equals 16. Hundreds 3 plus 7 plus 9 plus carry. Yeah, because that's basically, I don't know if I would have been able to track that all mentally, but that's what I basically did on the board. Okay, so let's thank this person. I guess it's more of a style thing. Personally, I wouldn't want to give an answer involving a function I had invented. Rather do it just in terms of C and T. Regardless, used a good procedure there. If you're interested in more practice problems like this, I can highly recommend Paul's online notes. This person was actually working on tank problems. So let me link him to the same page that I was just showing Thunder. Oh, there's no practice section for this one, though. One, 2, 3 times 111. Get 3. No, I already get lost when I try to do that mentally, honestly. Impressed I found such an easy math problem with that answer. I mean, you could just go into Wolfram Alpha and do 420, 69 factors. And just take whatever's in the middle. Look, I'll do it for 69, 422. Oh, okay, this notation kind of sucks. Like, I don't know what factors go with what here. Like, I assume this is our midpoint. It just looks right. But, I don't think it's that hard to get a, problem like that. How dare you assume that? You're right, but how dare you? I forgot to hit publish on my Go Live. Okay, there. Okay. No ingenuity, 5908. Do these answers look right? Oh, what the heck is this integral? Oh no, you can split it up. Value the following definite integral, include the concept of integration in your answer. Oh, they're nice and even tell you in the instructions to include that, not just mark you down. Okay, so it looks really ugly, but you can split this up into 3 fractions. So 2x to the 9th over x cubed. I hope that's not a negative sign. I hope that's just some kind of faint pencil mark. 5 times 1 over x cubed. Okay, then make you do some exponent math. Where did this 2 come from? They factored it out? That's not really necessary, but you can do it. Oh, just from that one. So yeah, you get x to the 6th, you get 1 over x to the 4th. There you get 5 over 2 minus 3 is minus 1/2. Okay, good. I agree with that. That looks good too, yeah. I like that. They even got the plus C. I think their work there for that first one was good. Actually, wait. Come back over here. 4 times 2, 5 over 3. Okay, yeah. They got their signs right. Okay, yeah. I agree with the first answer. Oh, double integration by parts? No, okay, they give you a nice U sub. Where does the person show their work for the U sub? I guess they don't. That's how much of a Chad they are, but they applied it right. Say you do U equals x cubed. Your du is 3x squared, so they cancel that out. You just get 6e to the u du. Equals 60 to the u. Okay, I agree with the second answer. The definite integral. It's definitely an integral. There you go. It's good. That's good. And that's good. 15x, that's good. They do the plus c. I probably wouldn't do that. Actually, I definitely wouldn't do that for a definite integral from 1 to 4. Where's there from 1 to 4? I guess over here. Okay, their notation's a bit off, but they plug this into a calculator. Hey, Bob. How's it going? Okay, so 4 cubed is 64. 15 times 64 is 640 plus 5 times 64. 5 times 64 is 320. Yeah, I think it's 320 plus 640 is 980. No? 960? Okay, I have Wolfram Alpha right here. Let me stop trying to show off. Just finish the stream for some experiencing Jeff problems. Yeah. It was 960. 99 times 69? Okay, you do 100 times 69 is 690. 690 minus 69 is 600 21? 621 final answer. Fuck me. Why can't I do zeros right? I did the same thing yesterday when Thunder asked me a problem. I was in the opposite. 6801. I did the mental trick right again if I just it did basic 69 times 100 right. Yeah, 6831. Wait, 21. No, 31. 31? That can't be right. Refund? All right, Thunder, just for you, I'm gonna I'll be peer pressured into refunding you. I did mess that one up and it complied with the rules. Oh, ducks. Yeah, I was doing the trick wrong in my head too, with the subtraction part. All right, so that was 960 plus 64 is 124. Minus 64? Okay. Never mind. So we're still at 960 plus 60 is 1020. Okay, so I agree with that. This, they probably just plugged into their calculator. 15 over 4 plus 1 is 19 over 4. Minus 4 is 3 over 4. Plus 15. Why did they get a minus? Oh, because they add the minus sign in front. Yeah. Okay. So why is that 1008? Isn't that 15? Am I being stupid? No, this should be 1004.25 if they're doing it like that. I don't trust my mental math skills right now, obviously, but okay, it is 1004. Okay. Problem 28. Actually, has anyone else replied to this? Not yet. Okay. Agree with problems 36, 26, and 27. For problem 28, actually, let's be sure that I'm not the one who's making the mistake here. Actually, that's not that hard to read. 15 over 4 plus 1 minus 4. 15 over 4 plus 1 minus 4 plus 15, I think. 15.75. Okay, yeah. So I think they did make a mistake there. All right, just one more problem for 29. Integral functions are used to measure accumulations. Notable applications are as cumulative density functions in statistics, where they represent probability of observing events. Use the fundamental theorem of calculus to find the following derivative of an integral function. D by dx of the integral from 2 to x to the 7th of tangent of t plus root t dt. Now, why do they do the chain rule here, but not here? Unless they mean that there's big, like, parentheses around that. Let me make sure that I'm not being dumb. But, nope. 2 to x to the 7th. Tangent t plus square root t. I don't know why I wrote square root like that when I have the thing, but it's fine. 'Tis fine. You can even do Laplace transforms. Oh, you do need to do the actual square root. Makes sense. I never even saw that you can do Laplace transforms and Fourier transforms. Dude, Wolfram. I just want to make sure I'm not missing something with how you apply the chain rule, the fundamental theorem of calculus. Okay, so here. Wolfram doesn't know how to do it? It's kind of funny. Okay, so here the chain rule happens. Oh, that's why you don't need chain rule, maybe. But what do you need? No. Huh. F of h of x, h is the upper bound. Well, no, you still need the chain rule on both of them. These problems always trip me up because I sometimes think you need the chain rule of the inside part, but I'm pretty sure like that the 7x to the 6 has to be multiplied by both of these terms. Oh no. Okay. I'm like 60% sure right now. Which for me is pretty high. Okay, yeah. The entire thing gets multiplied, not just one term. Okay. I feel confident enough in replying to this. Now, from 29, I believe the 6x, or the 7x to the 6 needs to be multiplied by both terms. So you'd want brackets around the tangent in square root. Or put another 7x to the 6 by the tangent. Okay, and I think that's all that needs to be said. So let's say it. Fast the sun is moving around the center of the galaxy. I thought they were gonna say how far the sun, or how fast the sun is moving around the Earth, and I was like, wait, that's not how that works. Well, our radius is 8 kiloparsecs. I don't know what units are supposed to turn it in as. Times 2 pi over 230 million, and you have your answer in kiloparsecs per year, don't you? Rotational speed to linear speed. Radius times angle, yeah. Sciencing.com. That's not, I don't think it's exactly what I want though. Oh, no, theta is 2 pi, because we're asking about a complete revolution. I think so. Linear speed equals 8 kiloparsecs times 2 pi over 320 million years. Eight times 2 pi over 300. 1, 2, 3, 1, 2, 3. It's not a... I guess 8 kiloparsecs is a really big number, though. Pi over 20 million. Oh, wait, 230 million, not 320. It's still going to be a really small number, but... What is that? 14,375,000. Pi over 14,375? 375. Kiloparsecs per year. All right, I think that's okay for an answer. 1225. What language is this? I'm curious. I'm betting Dutch. I don't actually know, though. Let's look at their translation, though, anyway. Certain volume of an enclosed space bounded by a sphere, x squared plus y squared plus z squared equals 4, and the cylinder, x squared plus y squared equals 2x. And they just need help. Okay, so we need to figure out if the sphere is bigger than the cylinder or the other way around. I assume the sphere is going to be bigger. So it's basically going to have it's like a normal cylinder, but it'll have a sphere for one of the caps, or maybe both of the caps. It's how I'm going to assume they've set this up, but we should graph this and verify. Actually, the cylinder is just defined two-dimensionally, so it's going to have to be that the, well, no, you can solve the cylinder going... That's really the equation for a cylinder? It's going to equal... Should that be a z? No, that's definitely an x. That's going to make a cylinder? Oh, maybe I can see that. Let's just look at it, though. X squared plus y squared plus z squared equals 4. That's a sphere of radius 2. X squared plus y squared equals 2x. Extend to 3D. That most certainly isn't... Oh, that's not the cylinder that I thought it'd be. It makes sense, though. No, does that make sense? It can only be defined for positive x's, because the sum of two squares must be positive. So you can never have x equals -1 here. Interesting. And I'm sure you could get this in a different format if you subtracted the 2x to the other side and did some completing the square stuff. Or just even like, you know, let's actually, I want to see, this person might not be able to graph this in like Desmos like I just did. So let's see if we can get a good, if we can play with the equation for the cylinder and get it something a bit more intuitive. So we have x squared plus y squared equals 2x. Let's subtract the 2x to the other side. Equals 0. And so now I want to be able to factor this. So I'm going to add 1 to each side, basically completing the square here. And then this factors to x minus 1 squared plus y squared equals 1. And two-dimensionally, that's just the equation for a circle with radius 1 centered at 1, 0. And this is defined for all z. So it's just going to be that two-dimensional circle projected up and down the xy plane. Okay, so that's how we can intuitively... And so now I think this is enough that we can know that the drawing must look like what we found on Desmos, because you can start by drawing the cylinder, which is the circle there, and that point there is 2, 0, 0. The sphere also has that same point. Oh, I didn't actually write the equation for the sphere, did I? Because it's radius 2 and centered at the origin. So on one hand, we have a cylinder going up and down. And then we also have a sphere. Okay. It's like a problem you cheese on the exam. Oh, really? I mean, technically, you don't have to do all this, like, lead up. But it's good to do that due diligence. I could also, I mean, actually, I was expecting a cylinder centered on the origin, to be honest. So I actually am even more glad that I did this. So now we make a decision about spherical versus... I mean, maybe you just do this problem with Cartesian coordinates, but it's going to be kind of painful. So I went to spherical or cylindrical coordinates here, and I assume spherical is going to be better. Let's see what... What does a cylinder look like in spherical is kind of the issue. Well, actually, can we just plug the, if we just use the formulas, we maybe don't have to worry about the conversion. Like, I don't think it's going to be that bad. So we have, oh, maybe it will be that bad. How do I want to do this conversion? So we need to express a cylinder in spherical. We need to express a sphere in cylindrical. Let's just try using spherical, I think, and just see what happens. Our conversion formulas are here. We might need to like add z squared to both sides for our cylinder, just so we can use this identity. I'm not really sure though. And I don't think Cartesian, just doing straight up in Cartesian is going to be worth investigating. I don't think. So would it be better if we use this format to convert in? I was thinking we might stick with that format for converting the cylinder into spherical. Because the nice thing about spherical is that spheres obviously are very easy to express, because this one up here just converts to rho equals 2. And that's your sphere. For this one, maybe let's not do funky adding z squared to each side things yet. Let's just try using our formulas for x and y and seeing how far that gets us. Okay, so if I come over here, we have x equals rho sine phi cosine theta. So we have rho sine phi cosine theta squared plus y is rho sine phi sine theta squared equals 2x, which is that. Okay. We got the sine phis, and we got rhos. Let's get everything onto one side. I know it should... What can we solve for here? We need to solve this for one variable, I guess. Can we solve this for one variable? This is looking a little ugly. We could solve it for sine. No, we can't even solve it for sine phi. That thing is messing everything up with its different power. So let's try the adding z squared to each side first, maybe. So we can use a different identity. X squared plus y squared plus z squared equals 2x plus z squared is what I was thinking. So this is rho squared, which is the point of me doing this. this over here is going to become something messy that I am hoping that we can just deal with. Sine phi cosine theta. Plus z squared is rho cosine phi. Squared. Hey, Shep. You want your cat? All right, just let me think about this problem for just a little bit longer, and then I'll get to the cat. That doesn't clean up very nicely either. Maybe we need to do this in cylindrical? Or I'm not understanding something about this conversion. I need to Google this a bit more. Let's draw Shep's cat, though. I'll do orange, I guess, unless I hear otherwise from Shep. Gonna be real good at drawing cats. All right. Purple? I don't have purple, Shep. And a tail. Get some stripes on it. All right, there you go. Okay. Awesome, glad to hear it. So I need to do some research into this whole cylindrical spherical thing. I'm pretty good. But you're doing okay. Expressing cylinder in spherical coordinates. Can't keep yourself awake? All right, Shep. Thanks for popping by then. Actually, is the sphere that bad? In cylindrical? When I actually look in the formulas? You'd have r squared plus z squared equals 4. Cylindrical might just be the answer here. I thought it'd be spherical. Or I could put that cylinder into cylindrical coordinates and then and then like do these in theory. Okay, so if I did put that cylinder into cylindrical coordinates, it would be r squared plus z squared. Oh, I know, it would just be r squared equals 2r cosine theta? I don't like this, dude. Will Decimus let me plot? Surely they let me plot in cylindrical. R squared plus z squared equals 2r x is cosine theta? And it doesn't like that. I don't know what to do with this. You and me both, buddy. Can I... Dude, I swear there's a way to do this in cylindrical. Here? Just for the view. What? Wait, what is Braille mode? Whoa, that's kind of cool. I never thought about doing like math and Braille like that. Okay, you have to have a way to do cylindrical, dude. It's just the way that the world works. Like, maybe it doesn't. Wolfram. Know what to do here, though, right? Let's see if Wolfram knows how to do this. Nope. You can solve this for Z, though, which... we can also do with the sphere. So I guess let's try doing this in cylindrical. Funny enough. I think it's probably that bad to convert, but kind of faced with an annoying decision. Actually, maybe even more sure that I'm not doing something stupid. Like, we can't just equivalently make it some other problem, but... I don't think so. I think we have to do this, or something like this. Okay, so... what I'm thinking is... I guess both these are going to be a little tricky to convert. Let's start with the sphere. Well, actually, I think that the sphere is actually going to be, ironically, kind of easy. R squared plus z squared equals 4. And because x squared plus y squared is r squared. And then if we want to solve this, I don't know what we want to solve that for yet. R or z. But if we look at the cylinder, we get r squared equals 2r cosine theta. So maybe we're going to have to solve it for r, but that's kind of annoying. If we divide both sides by r, is that dangerous? R equals 0 isn't really relevant. I hope we can safely divide by r here. Because then we can solve that for r. Technically plus or minus. Okay. So if we try to set up this triple integral now, what is this going to look like? Actually, that makes sense that r is 2 cosine theta, because that's just the polar form of a circle on the x-axis. I think. So we had to start... What do we start with? I guess we have to start with r. No, don't do... Ooh, maybe we do want this in terms of z. Oh god. This is... We don't want them both in terms of r. R should go from 0 out to the sphere. But that means for the cylinder... The cylinder being offset is what's making this so much harder. Wait, no. The radius should go from 0 to the cylinder. And the z goes from 0 to the upper part of the sphere when we multiply by 2. And theta, I haven't quite worked out yet. I assume 0 to 2 pi. Or is it negative pi to pi? Negative pi to pi feels like it makes more sense. Or, minus pi over 2 to pi over 2, I mean. I don't know if that's good, though. Does that get the entire cylinder if we do minus pi over 2 to pi over 2? Cosine theta at minus pi over 2 is 0. At theta equals 0, we get 1. Theta equals pi over 2, we get back to going 0. So maybe, I guess that is the answer. Minus pi over 2 to pi over 2. Let's see what we get. Okay, so if we're doing things... And we're doing this in cylindrical, so I need to get the inside of the integral right. R dz dr d theta, the order of integration doesn't matter. So So we just need an r there for the integrand. So if we start with r, then z, then theta, r goes from 0 to the cylinder, because r in cylindrical deals only with the xy plane. Our z, we're only doing the upper half, so we need to slam a 2 in front so we get both halves. Our z goes from the xy plane 0 up to the sphere. So 0 to root 4 minus z squared. I guess you could make that the minus root 4 minus z squared. Actually, wait. No, we can't integrate in terms of z and put another z inside. Hey, Storm. It's just, let me bring it up. It's this right here. I've been really struggling with the bounds. I was trying to do spherical coordinates at first. But the conversion seemed too difficult. So I switched to cylindrical. The conversion is easier, but the bounds I'm still trying to work out. But yeah, this is like the Desmos graph. Cylindrical is a good one? Okay. So what I put here is definitely not quite right. If I switch the order of integration, well, no, I just need to, if I want z to go from 0 to the sphere, I think I need to do z first. Let me just erase all that. So if I instead solve the sphere for z, just that substantial of a difference. I was saying I want to integrate in terms of z, then r, then theta. Z, I mean, we can do the bottom half to the top half of the sphere. Minus 4 minus r squared to plus 4 minus r squared. R goes from 0 out to the cylinder to cosine theta. Theta, I think, is minus pi over 2 to pi over 2. And I feel decently okay about that. I'm just concerned about the theta, the minus pi over 2 to pi over 2 part. Can I get, does Desmos do a polar grapher? I feel like it should. Actually, no, I can just do this in Wolfram. This is what I want to see. Considering we only get half. If you're not doing it in polar coordinates, I think that messed it up. There we go. Oh, so it does get the entire circle. Okay. This feels better now. Okay. So, if we're integrating in terms of z first. R integrates to rz. We're evaluating z from the minus square root to the plus square root. It's so, the worst part about doing like triple integrals is rewriting the bounds a million times. So we get r root 4 minus r squared minus negative r root 4 minus... Oh, actually, so we just end up getting the 2 in front anyway. It's funny. dr d theta. This is a u sub. 4 minus r squared. du is minus 2r dr. So we're going to end up with... that's going to be basically we're integrating root u. The 2 will cancel with there. We get a negative sign in front. Two r's cancel, just root u. Root u integrates to 2/3 times u to the 3/2. And our u was 4 minus r squared. d theta. Oh, the bounds. That's not going to be a pretty integral. Oh, we're going to get a... Okay, no, it won't be that bad. I don't think. Hey, Dan. Yeah. It's a busy day for math. Storm, you're saying c is plus or minus square root 4 minus r. I assume r squared. But yeah, theta from 0 to 2 pi. So 0 to 2 pi was scaring me because of the sphere. I thought we'd get the back half of the sphere that we wouldn't want. So it looks like we agree with each other except for the bounds for theta. So why did you say 0 to 2 pi? Because I thought that 0 to 2 pi was bad because it would include like this part of the sphere. So that's why I said negative pi over 2 to pi over 2. And I think those bounds still work for the cylinder. You don't think it changes anything? Okay. So in that case, I'll keep on going with my work, and then we can verify we can see if the answers match in Wolfram after. d theta. So to plug in, this is going to look like it's going to be complicated, and it won't be... it's going to be annoying, but not that complicated. 2/3 4 minus 4 cosine squared theta to the 3/2. And when we plug in 0, we get 4 minus 0 is 4. 4 to the 3/2 is 8. 8 times 2/3 is minus 16/3. D theta. Okay. Let me fix that 2, because it doesn't look like a 2. It's like a 3. So here we can factor a 4 out, and we get 1 minus cosine squared, which is the same as sine squared. Sine squared to the 3/2 is sine cubed. So we're going to have to integrate sine cubed. It's annoying, but it's doable. So we're going to factor the 4 outside. I said 4 to 3 over 2 is 8. Just verifying that mentally. 1 minus cosine squared is sine squared. Theta to the 3 over 2 minus 16 over 3 d theta. I'm going to have to erase this graph here. Going to come up here. Say minus pi over 2, pi over 2. I'm going to factor the 16 over 3 out as well. Make the numbers a bit cleaner. Sine squared to 3 over 2 is sine cubed. Theta minus 1 d theta. So integrating sine cubed, we can make a sine squared into 1 minus cosine squared, and then we get a u sub, I want to say. So I'm going to say the same thing as sine theta times 1 minus cosine squared theta minus 1 d theta. Then we do u equals cosine theta, so we get a convenient cancellation of du equals minus sine theta d theta. And we have the minus 16 over 3 outside. We have, my notation is going to be a little bit messy here. 1 minus u squared du minus theta from, this is horrible notation. I just didn't want the minus 1 to be included in the u sub. Sine cubed is odd? So it's going to integrate to 0. I guess sine is odd and cubed is odd, so sine cubed is also odd? I didn't even know that. It's something I even thought to check. That looks pretty odd to me. And the bounds are plus and minus. Okay, that's a nice trick. Okay, that saves some work. Equals 0 because it's odd. So we just end up with so minus 16 over 3 in brackets 0 minus theta for minus pi over 2 to pi over 2. So minus pi over 2, wait, minus negative pi over 2. That's not good. Maybe you're right about the 0 to 2 pi there. Because with this, I'm just getting cancellation with the thetas. No, wait, they add, right? Yes, I'm sorry, they add. Minus pi over 2 minus pi over 2. So we end up with 8 pi over 3. $16 pi over 3, I think. 16 pi over 3. Okay. Hey, Bootib. Oh, yeah. E2 pi aka Zach streams, and thanks Storm for that 6/3. And the person who we haven't mentioned yet is Ian Stuckey. Wait, why isn't that command working? Oh, there it goes. Ian Stuckey is second in the list there. Those are the other streamers who I know and can highly recommend. 6/3 equals 4 times the volume of unit ball. Oh yeah, it is. Because 4/3 pi r cubed. Okay, wow, that's an involved problem. I do want to check that thing with the bounds. Because that's interesting to me if it doesn't actually matter if you do 0 to 2 pi or minus pi over 2 to pi over 2. 0 to 2 cosine theta minus square root 4 minus r squared to plus 4 minus r squared. R dz dr d theta. Oh, come on, Wolfram, work with me here. Don't do me like this. Yeah, I'm going to verify both versions. Oh, don't do it numerically, Wolfram. It's doing it numerically. I mean, we can 19.2881. $19.2881. No, that's different. But so 16 pi over 3. Let me see if I made a mistake in my work. That's not either of the answers. What happened here? I put the wrong bound? dz minus pi to pi? That doesn't make sense to me. Why it'd be minus pi to pi, but... Wait, I thought pi over 2 made more sense. With this, it agrees with the 2 pi answer, though. I wonder why you get the entire thing. Actual education, thanks for the follow. Huh. Jump scare. Let's turn on the entire circle. I guess so. I was worried about the other part of the sphere. And so you could do 0 to 2 pi, but then you don't get the nice odd function. Identity. So I thought that this would... I mean, maybe the other bounds take care of it, but I was thinking that we would be including the volume of the back part of the sphere here where the cylinder isn't. but maybe that's just not right to worry about that. Maybe the R takes care of that. Oh, we do have the negative R's with this way, I guess. Oh, yeah, the R with the sphere being negative. Theta's for the cylinder, not the sphere. I mean, I thought it's for both, like they're sharing it. But I think maybe this is like that negative sign is what saves it. Because the negative radius makes it point back out towards the cylinder, is what I'm thinking. It's a tricky thing to visualize that. So yeah, it's going to be times minus 2 pi. So it's actually going to be minus, oops, plus now. 32 pi over 3, which is whatever, 8 times the unit ball. Huh. Interesting problem. Coordinate choose are inside the cylinder. Turn with theta, our integers to say in the sphere. This is freshman year calculus? Oh my god. I wasn't doing this my freshman year. Actually, I could have taken calc through my first year though. My advisor person said not to, even though I probably could have done it. Okay, so maybe that's not that ridiculous. Oh, really? With like this graph here? What I was imagining... Oh, it's all good, Storm. You don't have to... like, get up for it. What I was thinking is that if our radius starts from the negative... I wonder if, like... If we went from pi over 2... Yeah, exactly, Storm. So if we started, like, from pi over 2 and went out and around to plus 2 pi... That's 5 pi over 2 if you do one more revolution. I don't feel like we... Desmos does polar, right? Oh, no, not 3D. In 2D, it hopefully does polar. I hope it does. It's going to be really annoying if it doesn't. So I want to play with the bounds here. This is the two-dimensional situation we have going. Okay, Storm. Okay, if we do the standard 0 is less than or equal to 2 pi, we do get a complete circle there. But what I had thought would be valid is if we, oh, whoa. Minus pi over 2 to plus pi over 2 is also a complete circle. And if you keep going around like more evolution, you're just drawing the same circle repeatedly. So if we did it 0 to pi, that's also a complete circle. Okay, and so Storm, you're investigating first spherical. Circumference, you love pi, glad to hear it. There's been a whole lot of pi talk today. I was just doing a crazy calculus like integral, and we're just trying to figure out if this is the right answer or not. We have the right answer, or we've doubled it, I think is what we've narrowed it down to. Fan bounds for theta and phi, right? Oh, wait. Yeah, if R is equal to 2, that's just always the entire thing. Doesn't make sense to bound theta when it's like that. Yeah, Storm. I think I ran into that same thing with spherical. Phi goes 0 to pi. Oh, yeah. 0 to pi for phi makes sense, yeah. It seems easier to just solve a geometry problem at each slice parallel to the xy plane, then integrate the area. Is that J. Chow Isaac? I'm sorry if I'm saying that wrong. That's an interesting idea. You maybe could get that in like a single integral if you take that approach. You ever? How would that look though? Am I drawing in 2D? Oh yeah. This one? Yeah, I think I see kind of where you're going with that, J Chow. It still seems hard to express that, I guess, all in one go. Theta from 0 to pi. Okay, I got that. I don't know. I don't think I can do it for the circle there, though, unfortunately. If it's from 0, 0 to the red circle. Wait, in spherical, theta is going from 0 to pi, you're saying? Or just for this two-dimensional graph, you're saying that? From 0, 0 to the red circle. Well, that's 2 cosine theta. Except, oh, when we transfer into spherical, that needs to be different. I'm pretty sure phi is the vertical angle, isn't it? So yeah, for spherical, theta is like in the xy plane, and phi is coming down from the z-axis. That's the way that I've always known it. Oh, okay. Do you guys do it differently? Okay. As long as you know what we're referring to, I guess. And so, what would phi be then? Because the spherical, that doesn't really help with that problem, I guess. Do you do the entire sphere or just part of it? Turn it into the circle equation? Okay. Actually happen to already do that right there. X minus 1 squared plus y squared equals 1. Right? In JChat, I'm still thinking about what you're saying, but it doesn't seem easy to me to get the areas of each slice, so I'm going with this thing that Storm is saying for now. Then the red circle is described by that, right? Now take a point on this circle. We can have the point 1, 1 works, right? Because the x becomes 0 and 1 squared equals 1. Calculate the distance from this point to 0, 0. Let's root 2. Take a point x, y. That's what I did. X equals 1, y equals 1, right? Trying to think if there's something. I'm trying to figure out like where you're going with this. R phi. Okay. Oh, you mean just a generic point, x, y, not an exact point. Well, I mean, isn't that r equals 2 cosine phi? Like, if that's what we already have. Unless, like, we could, like, solve it for y and say that our generic point is x comma plus or minus root 1 minus x minus 1 squared. And somehow convert that into polar or spherical, but in this case it's going to be the same because we have no z. So I think it'll be the same. I don't know. Okay, here. I'm going to try just Googling this problem because I feel like it's already been solved somewhere. And like the more that we're going back and forth, the more I become unsure that like they take a lot of convincing for me to feel like that we have the right answer here, I guess. The integral will be theta from 0 to pi, phi equals from bound of our definition, r from 0 to r phi. R squared sine theta dr d theta d phi. Zero to pi. No worries, Storm, you don't have to. You do as much or as little as you want. Let me, I do want to just Google this, because I feel like this kind of thing has been solved. It's hard to do this stuff when you're just like in bed. Enclosed space bounded by a sphere. And I just don't want you to get out of bed just to do this problem. And x squared plus y squared equals 2x. Just see what other people are saying. Ugh, this is the easy case. The cylinder is centered. I think you should do in bed is counting. Okay, this is a very similar case. It's just, ooh. You do integral for counting? This person does 0 to pi for a cylinder that's on the y-axis. Hey, sad guy. Yeah, sure. What's the question? You can type it in chat there, or if it's easier, yes, thank you, Jed. You can put you can put it in my Discord, like if you have like a picture or something. It's actually a little bit of a special case with the A. Do we have the same? Actually, we have the exact same case though, because A equals 1. We just have x minus a squared instead of y minus a squared. They do 0 to pi. That makes me feel like I should do minus pi over 2 to pi over 2. But yeah, sad guy, as soon as you post your question, I'll work on yours. For now, I'm just working on this like calculus one, but I'm happy to help with any level of question that I know. X to y is 2 to 5, and y minus x is 33. Find the value of x plus y. Okay. I can certainly do this. So it's like a ratio question mixed in with a system of equations. I don't... I'm going to erase... I think I'll be able to erase this part of the work, and everything else can squeeze in. So just kind of ignore the stuff that's happening here, completely irrelevant. I'm going to solve that, you smart. So let me copy down what you put. We have x to y is equal to 2 to 5. And y minus x is 33. And we want to know what y plus x is equal to. So the very first thing I do here is I don't like this format at all with the ratios. Thankfully, it's the exact same thing as fractions. So I'm going to rewrite this as fractions. X to y is the same as x over y, and 2 to 5 is the same thing as 2 over 5. And from this point, we want to solve one of these in terms of x or y and plug it into the other. What comes naturally to me, and it may not be the same for you, is taking this one on the left and multiplying both sides by y. So I'm going to do that, but there are many ways to solve this thing. The y's here will cancel. So we get x equals 2 over 5y. Now that we know this fact, we can come over here to this equation and plug it in. So y minus, now we know x is 2 over 5y is equal to 33. Now we just have some fraction math to do here. Y minus 2 over 5y, that's the same thing as doing 1 minus 2 over 5, which is the same thing as 5 over 5 minus 2 over 5, which is just 3 over 5. Sorry, that's getting kind of messy with my drawing, but so we know that so y minus 2 over 5y is 3 over 5y. That's what I'm trying to say with that, is equal to 33 still. And I'm going too fast, please let me know. You guys smart? Okay. Yeah, I think Storm already worked it out, but I'll still go through and explain it. Solve this for y, we multiply both sides by 5 over 3. Times 5 over 3 times 5 over 3. This all cancels in front of the y. The 33 cancels with the 3. That's 1, and that's 11. So we get 11 times 5 is 55. Okay. Now we can take this y equals 55 and plug it into either of these equations. I'm going to do this equation because I see we get a nice cancellation with over 5 and 55. So x equals 2 over 5 times 55. 5 and 55 cancel. 5 becomes 1. 55 becomes 11. We get x equals 2 times 11 is 22. So x is 22, y is 55. So x plus y, or y plus x, or whatever, is 22 plus 55 is 77. And that's our answer. You did the exact integral last year, Storm? But yes, guy, I hope the explanation makes sense either for me or Storm. Let me know if you have any questions, though, or if you have more than that. And thanks for the follow-up, by the way. I'm not a teacher, I'm just a tutor, and I'm enthusiastic about math, basically. And I do these math help streams on Tuesdays, Thursdays, and Saturdays, starting 2 hours ago, if you ever have more questions. There's also a schedule I've uploaded on Twitch. If you're on desktop, it's down below. If you're on mobile, I have no idea where it is. Gotta be a top student when you're in school or something. I mean, I did well in school, but I feel like smart is a strong word. If you want to help on your degree of a mapping manifold, I have heard of manifolds. I don't want to even delve into that. Wait. This is almost the exact same problem, just the same thing as the last one with it's y minus 1 squared instead. So they did only the upper half, which is fine. They say it should be the same exact volume, 16 pi over 3. I think my minus pi over 2 to pi over 2 thing is right. I think my first thought was good. Demonstrating the Harry Ball theorem. Oh, nice. I have looked that up before. And this is I forget it, like we were talking about before, and like it's related to a whole bunch of other theorems in abstract algebra, or whatever it's called. Topology, maybe. I don't know. For all those high level maths, I don't know where the lines begin and end. Did this year for your memoir is to show the Poincare-Hopf theorem. Oh, and I see that's mentioned right there. Hey, Cosmolano, how's it going? Thanks for the follow. Good luck with that. I guess I don't. Storm. Do you like physics? I like it. I'm not very good at it though. If you have a question about physics, if it's like a very basic one, I might be able to help. If not, I might be able to find someone who can help. Sometimes people who know physics around. Like, what type of question is it? If you do have one, or if you're just asking for fun, if I like physics, then QFT and curved space-time? That's going to be a little too advanced for me. Quantum field theory? I'm sorry, Cosmolano. That stuff is very interesting. Oh, Storm is feeling brave, though. If you want to put your question to me, maybe Storm is up to it. I'm definitely not, though. Unless Storm is referring to Sad Guy. So Sad Guy, you're saying the ratios of 1 hour to 112. Oh, you also do physics, Storm? Okay. Well, yeah, Cosmolano, then Storm might be your person. The ratio of 1 hour to 112 hours is 1 to 5? What's the 1, 1, 2? Sad guy. Oh, quantum mechanics, I think. You're not sure what to call it? Like they're being divided? I'm trying to think what that could possibly mean, side guy, but I'm not sure. Hey, Super Salmon. What type of math, if you don't mind me asking? The number on top of a number? Okay, so let me like write this out. Looks like Stormware already has a general recommendation for a Super Salmon, but depending on what you're studying, I definitely would have one big suggestion. But it doesn't, this website that I really like doesn't cover every topic, so that's why I'm asking for what type of math. Okay. Okay, so side guy, your question is the ratio of 1 hour to 1 over 1 over 2 is, and you think it's, or the answer that you said is 1 to 5? So is it 1 over 1 over 2 like that? And Salmon, the one that I like to recommend people is Paul's online notes. It covers algebra, calculus, and differential equations in trig. So if you're doing any of those classes, I highly recommend this site. But it doesn't do like stats. So if you're in that class, that's why I didn't want to recommend it. One to the side. So is it like 1.5, like a mixed number? Oh, that would make sense if it's a mixed number, like 1.5. Okay. I get it. So let me actually do that. Okay. 1 hour to 1.5. I don't think our answer will be 1 to 5. I think it'll be 2 to 3. And so how I would solve this problem is you interpret the word 2 as division. And so basically it's 1 divided by 1.5. And that's difficult to do in this current format because mixed numbers, I think they're kind of annoying and not that helpful personally. But of course, if that's why you're given the problem, you can't control that. I would convert this to an improper fraction. And the trick that I always learned for that is you do the denominator times the whole number, so 2 times 1, and then you add the numerator. So 2 times 1 plus 1 is 3, and then you keep that same denominator. So 1.5 is the exact same as 3/2. And that's the conversion trick that I learned and always still use. So this problem is also the same as 1/3/2, which to me is much easier to deal with because this fraction here on the bottom, dividing a fraction is the same as multiplying by the reciprocal. So I'm going to say the same thing as, 1 times 2/3, because the reciprocal is when you flip that fraction. And 1 times 2/3 is just 2/3. And like in the last problem, fractions are the same as ratios, so our answer would be 2:3. Should that be flipped? Because if you multiply that by 2 and that by 3, those aren't the same. Or am I just... Should be for every 3 of these, we have 2 of those, right? Can I do like math like this? This is like a wording thing, because do you actually need to do the... Maybe I actually flip the fraction. Let me... Okay, I'm just having a brain fart moment here, sad guy. Oh, okay, I guess the answer is 2-3 then. If it's multiple choice. Okay, I'm glad that kind of saved me there, because I was about to like Google a similar problem. I'm curious to see what Cosmolano was asking about, because I kind of skipped over. What is the derivative of a commutator? Oh, and yeah, I never heard of those. Wow. Yeah, no, I definitely can't help that, but I'm glad that Storm seems to at least know a bit about it. No worries, sad guy. Glad to help. Okay, so... Oh, that's right. I was Googling this. I was still in this calculus problem. Oh gosh, okay, so... The bounds of this are definitely tricky, but I really do feel... The more I look into it, the more I do feel like it's... minus pi/2 to pi/2. But I accidentally closed out of a search that I didn't want to there. Because in this case, when they have almost the same thing, but with y minus 1 squared rather than x minus 1 squared, they do 0 to pi. Rather than 0 to 2 pi. So let's look at Quora. Quora is never wrong. Oh god, please. No, oh, that's the easy case as well. It's the easy case. high score, bro. You got me a little bit there. Can't lie. All right, I think I'm feeling confident enough to get back to this person. Need help with exercise 12. Okay, so they didn't write that much about what part they're actually confused on. I'm definitely not going to go through and type out the execution of this. Spectry, at least a month, I think. They've been around for a good bit. I have more slots too. I just need to figure out what to use for them. Twitch just doubled everyone's animated emote slot, so I really got to figure something out. I love it, being my salesperson. A tricky one. Cylindrical. Converting to cylindrical is much easier than spherical. If we convert to cylindrical, we get r equals 2 cosine theta for this cylinder. And I solved this here for z. Plus or minus square root 4 minus r squared for the sphere. Actually, not sure. I think it's enough information for me to go learn more, make a better question. Okay. Glad Storm was able to help you think about it more. And thanks, Storm, for jumping in on that, because I've never studied quantum field theory. For the bounds, we can use z equals, I started with z, right? Yeah, okay. Minus square root 4 minus r squared to square root 4 minus r squared. Or no worries at all, Cosmolano. I never mind this being used as a room to help people out. For r, we go from r equals 0 to 2 cosine theta. And for theta, we go from minus pi over 2 to pi over 2. This is the part I'm least sure about, but from looking at similar problems, I think it's correct. Oh, okay, Storm. No worries. Oh yeah, you actually do get symmetry with the YZ plane as well. Actually, they get that. Well, actually, that part kind of worries me. Why did they get a constant? 16 pi over 3 does not seem the right answer. Actually, that's a good point. The total volume of the sphere is 32 pi over 3. And 16 pi over 3 does seem way too big. It doesn't need to be less than half. So did we make a mistake here? By we, I mean I. But no, I even verified this with Wolfram Alpha, right? $9.6. Oh no, I did not. So I got 16 pi over 3. I did make a mistake in my actual integration, I guess. Where's my mistake? So I think my limits, the setup here is okay. Well, okay, I messed with my bounds a bit too much here, but hey, Zach. For the bounds, we must have 2 cosine theta equals 1/2, cosine theta equals 1. Okay. Oh god. Okay. Let's erase this other question since we're done with that one. Okay, so the thing is, even if I make it, the center of the cylinder is 1, 0. I agree with that, yes. Just to rewrite what the initial equations were, which is also equal to x minus 1 squared plus y squared equals 1. Okay. So it seems like maybe that sign isn't supposed to become 0. Oh, maybe we do need to do the 0 to pi over 2 trick. Oh yeah, we should not use that odd function identity storm, because I think that just it shouldn't zero itself out, because there clearly is volume there, right? Or well, I guess you still get the volume from part of that. I wonder if that's the mistake. Instead of doing minus pi over 2 to pi over 2, we do 0 to pi over 2 times 2. And that forces us not to use that odd identity thing, and that... Let's try executing this version of it. So I'm going to get rid of that last line. If I just don't use that odd function identity and I do this version instead, which should be the same. So I feel like my math, like on the inside, was pretty okay. What do we get in this situation here? I think I'm just going to bite the bullet and integrate sine cubed. It's annoying, but it's not that bad. I'm going to factor out the 16 over 3, though. And 16 times 2 is 32. Okay, so I'm going to say u equals cosine theta again, and I'm just going to see what this comes out to. If it's the same thing and I did work for nothing, then who cares? But 16 pi over 3 definitely can't be right for the reason that stack exchange thread pointed out that it makes no sense for this volume to be half the total volume of the sphere. So that's sine times 1 minus cosine squared. The sine cancels out. It's just like integrating 1 minus u squared. We have a minus sign from the u sub. So it's just like integrating... I'm doing a little less in my head, but we get 1/3 cosine cubed theta minus cosine theta? I'm doing too much of this in my head. Let me just write this out. I think that's right, but I really don't want to make a mental math mistake here. Okay, so we get minus 1 minus the u squared du minus theta. 0 pi over 2. Those bounds aren't right. And then I distribute the minus sign inside. I did do it right, I think. One-third cosine cubed theta minus cosine theta minus theta from 0 to pi over 2. Okay. You agree with minus pi over 2, pi over 2? Okay. Thank you, Storm, for thinking about it. It's probably the last thing I'd want to think about when I'm in bed about to fall asleep. I appreciate you working on it. Okay, what does this come out to? Cosine of pi over 2 is 0. That's convenient. So we get just minus pi over 2 from the first bound. Minus cosine of 0 is 1. 1 cubed is 1. 1/3 times 1 is 1/3. Minus 1 minus 0. minus 32 over 3. That's going to become minus 2 over 3 minus minus 2 over 3. I'm just going to do this the old-fashioned way. Plus 2/3, right? Right. Get a common denominator. 3. I mean, is that really even that important? It's not. Just multiply the 32 over 3 in. 16 pi over 3 over 6. No, over 3. Minus 64 over 9? Kind of pleasing that they're both squares. Like perfect squares. Does that match with the answer from Wolfram? Yes, Storm. I stole it from Stack Exchange. I think using the odd function identity there, I guess that's what messed it up. 9 over 5 plus root 9 over 5. Oh, really? .141. Oh, yeah, that's pretty close. That should be a 5 if it was pi, but it's one of the better ones that I've seen. 22 over 7, I don't think it's as good. Yeah, it's already off in the 3rd digit. Think Ramanujan? Oh, that makes sense. And so let's make sure that this matches the 9.644 that Wolfram gets. So we said it was 16 pi over 3 minus 64 over 9. 9.644. Okay. I feel much more confident about this now. Let me just refresh and see if anyone else has commented on this before I respond. No. Okay, good. We did a lot of work to get this answer, but I feel confident about it now. All right, Storm, thank you so much for helping with the problems today. Sleep well. Oh, and Super Saiyan, thanks for the follow. Okay. First, if you're... Oh, yes, Super Saiyan. No, it's not 2 frames. If you ever played the game Fallout New Vegas, or even the older Fallouts too, that's the flag for the New California Republic, which is like a faction in that Fallout universe, I guess. So it's the flag for the state of California, but because in the Fallout universe everything was nuked and like radiated, it's a 2-headed bear. Yeah, it's from a video game, basically, if you haven't played Fallout. To graph this with Desmos or similar, you can figure out what it looks like intuitively by rearranging the equation for the cylinder. Subtract 2x from each side. Add 1 to each side to make factoring easier. And you get x minus 1 squared plus y squared equals 1. A circle of radius 1 centered on 1, 0. It becomes a cylinder since the in 3D since the equation is valid for all z. Okay, so that's the intuitive note I wanted to put about how they could figure this out if they're not allowed to use technology to graph this. I found that converting to some is using converting to spherical. However, this volume is symmetric with respect to the xz plane. So I want to test something. If I make, this should be the same exact result, but if I do that, cutting the interval in half multiplied by 2 thing, we should get the same answer. I just want to do a sanity check here. Oh no, Wolfram, you can't figure this one out? We could figure the other one out? Come on. You know how to do this. I believe in you. I could give it the first step and just make it a double integral too, I guess. I think let's do that. If we boil it down to just a double integral, it would be 4 double integral 0 to pi over 2, 0 to 2 cosine theta. Of r times square root 4 minus r squared dr d theta. Hopefully Wolfram can do this exactly. I'm surprised I can't do a triple integral in time, man. Oh, cannot do a double integral in time either? Alright, fine. I'm posting this. Who cares? I'm sure it's right. So we should instead make theta go from 0 to pi over 2 and multiply the integral by 2. This helps prevent negative areas from, or negative volumes from canceling. For the final answer, I got 16 pi over 3. I'm giving the final answer to here because I had so much trouble with this that I want them to be able to know if they got it right or wrong. So I'm pretty sure this is right. Okay. I think these integrals are really fun, but god dang, that one was not easy. I do see that I have mail. Let's go check that. Oh, they deleted the original post? Oh well. Alright, let's look for new questions. Geometry. Let's look at it. Textbook doesn't have an answer key. They want someone to check their work. Writing in cubic meters. I don't know if the form's already converted to cubic meters or if I need to do it myself. Ooh. Interesting. of the cones in the figure. So you have to adjust the cones individually at first, and then you add in the volume of the cylinder. Okay. And so what did they do here? 1/3 pi r squared h for the volume of the cones. So I like, dude, their handwriting is so neat. So they get 12.57 for one of the cones, and they multiply by 2 and get 25.14 cubic meters. That's good. And then to get along with the entire figure, they need to get the volume of the cone, or the cylinder, which is just pi r squared h. Then they add in the, yeah, this all looks right. Let's even verify the numbers too. Thank you, Jed. It does matter, because I always am scared that I'm going to post and miss something stupid. Or that, like, I did something stupid. 75.39. Yep, 75.4 is close enough. Okay. Conversion necessary. You can by it because the initial measurements are given in meters, and the formulas involved require multiplying 3 measurements involving meters. Radius twice and height once. So you end up with m cubed. Okay. Post that. Okay, that geometry problem wasn't painful, thankfully. That emote is super cute too. The p-value method, it was great. That's awesome. I'm good. I've got a real webcam now, so I have like 2 cameras. So I have my old phone cam that's like this big one, and then I also have the webcam that's up there, so I can like try and like toggle between them. I don't have to like do his crazy poses to get myself all in one frame. So that's been nice to have. But back what they asking about, so they're saying the p-value method, which is quite a few different ways to get p-values. Let's see what the actual situation is. 18% of all high school students smoke at least 1 pack of cigarettes. 18%? What kind of high school are at Wilson? Okay, this has to be made up. There's no, or it's like or it's from like a long time ago. That seems a little high. It's like the same with 300 students found that 50 students smoke at least 1 pack of cigarettes per day. Alpha equals 0.05. Test the claim less than 18% of high school students smoke at least 1 pack of cigarettes a day. Okay, so we're dealing with proportions here. We can use the because we have a pretty high sample size. Use the p-value method. I guess the other method is the confidence interval method, which is basically equivalent, or it really is equivalent, but it's a weird way to say it. I've never heard it called the p-value method before. Regardless, their null is that Population proportion equals to 0.18. Makes sense. The alternative is that it's less than 0.18. The sample proportion is 50 over 300, which is 0.17, just below 0.18. So the formula for the z-score. Sample minus population, or minus basically like the null, divided by p times q over 300. The p-value, they got 0.2743, which would definitely be failed to reject, which they also did. So what was the actual question? Oh, okay, so it's really just about the phrasing. Their work seems perfect, though. Oh, they do have a second one there, too. Let me just quickly look in a z table. Their z-score was minus 0.6. On this column, yeah, 0.2743 is perfect. I didn't actually verify like this math right here, but it seems about right. So let's look at their second one. Mean salaries of elementary school teachers is greater than the mean of the salaries of secondary school teachers. Okay. The mean of the salaries of random sample of 26 elementary school teachers. Sample standard deviation, okay. So here they're using t, which could be correct. The thing I hate about two-sample t is that it gets taught differently. They're doing it the way where you assume the population standard deviations are the same. I need to look at this again. Actually, I don't like this website, did I? I preferred... I don't remember which one I preferred. I'm just gonna look at this one though. That's what I don't like. I'm just gonna take them at the word maybe though. Or maybe not. Maybe you do do the same thing. User degrees as the smallest. Oh, you don't add them. Interesting. Or there's the complicated formula way, I guess. That's kind of... God, they're even giving two different ways. I hate this. Because I know the way that... Or, I mean, I can remember the way that I was taught, but that doesn't do any good for someone who's taught differently. The thing about stats is that neither is wrong. Okay, let's just look through their work. That mu1 is greater than mu2. I agree. That's our alternative. That's their null over there, and it's a bit cut off. 19.21. What did they say the degrees of freedom were? I don't see it listed here. I don't know why there's a wizard there. Do they have a t-table? A bunch of things on Z. I guess it is ztable.com, not ttable.com. Oh, but then how? The less degrees of freedom would be 23. We're doing one-tailed for greater than? Alpha is 0.05, is it 1.714? Is that what they got? Oh no, 1.921. I don't know if they're wrong though. Okay, but what I can say is that phrase before. Normal distributions in T distributions, as you did in the provided examples. And there's more ways than that. I think they're saying to use a p-value to test the claim rather than a confidence interval, which can also be used to test claims. But this is less common. I agree with your work for the first example. Involving the rate of high school students who smoke. And I agree with the use of a two-sample t-test for the second example. I have a hard time verifying the work for a two-sample t-test, though, because it gets taught different in every class, it seems. If you like, instead of finding a t alpha value, oh, like just finding the critical t score or z score. Okay, that makes sense too. I'll mention that too. I definitely have seen the confidence interval way, where the you make a confidence interval based off your sample, and if the null is outside of that interval, then you can reject it. But that might be what you're saying too, Zone Ranger. Yeah. P-value rather than the critical Z or T score. Either way, you give the p-value in your work, so you should be fine on that front. Okay. I think that's enough. It's already been 3 hours. Wow. There's been plenty of questions today. That's great. And also, I want to keep on going. Calc 1, check if these answers are right. Let's just see how involved this is going to be. Ah, dude. Just do that and call it good enough. Okay, so problem 10. The following TLIs are based on the continuous function f of x. We have all these. Hey, Ben. Now the stream can start. Thank you. I was just like awkwardly sitting here until you got here. Glad you have graced us with your presence. With your presence. The minimal number of zeros of f of x guaranteed by the intermediate value theorem. Well, there has to be a zero between these numbers. We're given it's continuous, importantly. So there's 1, not guaranteed, 2, 3, and 4. Where are they getting 5? Wait, 1 and 2 and 3 and 4 and 5. Oh no, I just miscounted. So every time it changes signs, so negative positive is 1, positive negative is 2, negative positive is 3, positive negative is 4, negative positive is 5 again. Okay. Focus on why the IV. Oh, that's just a hint there. Okay. So I agree with 10. Just write some notes here. A rabbit is running down a rabbit hole. Position is well modeled by a function of time called s for times t greater than or equal to 0. Let s of t equals s's position here. Okay, s of t is 8t cubed minus 96t squared plus 360t plus 5. Okay. Answer these questions about the rabbit's instantaneous rate of change. Time intervals moving forward. Okay, so this is basically a sine chart. So they take the derivative, set equal to 0. 24t squared. 96 times 2 is 192, good. Plus 360 equals 0. Thank you, Donkey, for the gift sub. Wow, thank you. To Zone Ranger. It's very nice of you, Donkey. And God, that Arrested Development quote is one of my favorites. I appreciate you, Donkey. So what's happening? Okay, zoom in and enhance. T minus 5, T minus 3. Okay, yeah, that's good. So our zeros are, for the derivative are at 3 and 5. Before 3, oh, it's annoying. You plug in 0, and you get a positive number, so positive. Between 3 and 5, you can plug in 4 and have to do actual math, and that sucks. Actually, it's a cubic. It has to behave like that once you know the first one. So yeah, I agree with our intervals here. Yeah. Oh, well, there's a little subtlety where maybe you want to do 0 to 3 because the function is only defined for t greater than 0. It's, wow, with lower values first, would they get marked down for 5, 3? This feels like the teacher is going to be very particular here. So let me actually add this in. Answer for 10 or 11. Your work is right, but the instructions are pretty specific, so I want to mention 2 things. S of t is only defined for t greater than or equal to 0. So your first interval minus infinity to 3 should be 0 to 3 instead. And then the instructions for the stationary point say to start with the lower value. So it should be 3, 5 rather than 5, 3. I really hope you want to get marked down. Okay. So let's look at 12. Differentiate f with f of x equals cosine to the 9th of 18x squared minus 4x plus 6. That's just being annoying with the chain rule. It's not fair. They didn't do the chain rule right, though. So they did the first part of the power rule correct. Then they differentiated the cosine, and they made it sine. It should be negative sine, and the power does not transfer over. It should be just sine, not sine to the 9th. And then the last part of the chain rules, they derived the inside, and they left off the x. It should be 36x minus 4. Okay, so we got a few things to... For 12, have the right idea, but not executed quite right. The first power rule on the power of 9 is correct, but the sine to the 9, but the next part with sine to the 9 isn't right. When doing the chain rule, the outside power doesn't stay there, so it should be just sine, not sine to the 9. I need to throw in the thing about the negative. Also, cosine derives to minus sine. You need a negative for that. Finally, the last part of the chain rule. Last part of the chain rule. It should be 36x minus 4 rather than 36 minus 4. Okay. 13. Got some rapid fire differentiation. 18 times 9, is that 162? Yeah, it is. That part looks good. You have a product rule on this one, 6e to the x plus, okay, yeah, the product rule is good, minus 9 cosine x, that, okay, yeah, these first two are perfect. Then there's a quotient rule. What? Oh, they do the numerator separately. Okay. So when doing the quotient rule, start by deriving the numerator. 2x minus 5 derives to 2x. The denominator just comes there as normal. Do minus. The denominator also derives to 2x. Okay, that threw me off for a second. Okay. They multiply everything out. Get some cancellations. Yeah, this person's a champ. They handled that problem 13 perfectly. For 13. Then the last one, problem 14. The following data about three functions f, g, and h. F of 3 is negative 2. F prime 3 is 1. What's the question? Find the values of the following derivatives. Oh, I get it. They're making you like generically apply the product rule and all that stuff. So d by dx of f of x times g of x is going to be, they don't really show the formula, but which one are they deriving first here? They're deriving g first. So g prime, or no, they're deriving f first. F prime of 3 times g of 3 is 1 times 1. Then f of 3, negative 2, times g prime of 3 is negative 1. So they get 1 plus 2 is 3. I agree with that. Then you have to do quotient rule. You derive f first. So 1 times 3, or it's 1 times 1 is 1. Minus, and then derivative denominator, minus 1 times minus 2. I agree with that. Over the original g of 3 squared. Negative 1. Okay, so I agree with that. Then you have a product rule and a quotient rule because they're just mean. This person does not... Oh, wait. Did they reuse their work? No. They reused their work from d by dx f of x times g of x. They reused it down here. That's not going to fly, though. They need to do the quotient rule again, unfortunately. And the quotient rule is going to involve a product rule. So this answer will be involved. Actually, will it? Yeah, it will. But not that simply. Okay, for 14... rule again, which will involve doing a product rule inside where you can use your previous work. To be f of x, g of x prime, k of x, I need brackets. Times k of x minus f of x, g of x, k prime of x, close brackets, over k of x squared. So hopefully spelling it out like that helps them see what I'm saying. Empirical rule? Oh, what is that? Is that with stats? Oh, is that the 68, 95, 98, 9.7? It is. Okay. What's their question? They have normal distribution with mean 12.4, standard deviation 2.7. Above what length is 16% of the largest lengths? Wait, above what length? Are they asking what the last 16% of the normal distribution is here? That's how I'm interpreting this. So it's like a percentile question. %. Yeah, Dan. And I think it's actually a convenient thing because 16 times 2 is 32, and 32 plus 68 is 100. So it should be right on that one standard deviation mark. Should we think that they're right? I can do it the old-fashioned way too. I can like let's get a z table. Because a way that we can also do this is basically go on what Dan put, where getting the last 16% of the normal distribution is like getting the first 84%. So we can look on the inside of this chart for the closest thing to 0.84, which, I mean, we can take either. Oh, wait, I mean, it's just 1.0, I guess. It's either 1.0 or 0.99, depending on your persuasion. Actually, it should be 1.95. Because I feel like I've had to use 1.95 as a z-score before. And you could use that with the formula for a z-score. But if it's just one standard, that's just a z-score of 1 is just one standard deviation above the mean. So I think your answer is just right. (15.08) using the inverse norm. Okay, yeah, so it's not exactly at 1, I guess. They get 15.1, so as long as you round it, it's the same. Thanks for checking that with the calculator. And they actually did do it that way with using the formula for a z-score. I think it's x minus mean, though. Z-score close to 84%, 1.0. Okay, well done. Yeah, I was taught it both ways. Like, they taught us how to use the z-charts, and then after that, they taught us how to use the tables or the calculators. Okay, this person's just saying thanks for that Calc worksheet. I think I was just switching over to Learn Math. Finals week coming, Donnie? Yeah. You can't solve this for R. There's an R trapped inside the log, and there's an R on the outside of the log. There's probably a numerical solution. And why is it given like this? Okay, so 1440R. solved by graphing? Yeah. I mean, unironically, 1010 times 2, 2020 log. Oh, r equals 0. Wait, really? Like, because log of 1 is 0, yeah. It does get a numerical... Yeah, no, you can't do this. Algebraically? I actually got that right on the first try, wow. I mean, is observing that r equals 0 solution, does that count as algebra? I mean, from observation sounds really like pretentious still, I guess, or like something you'd say in like an academic paper. A solution that can be found somewhat easily by intuition. Sure. I mean, I guess say by observation would be a lot simpler way to say that same thing. Hey, intelligent nerds for life, hell yeah. Is r equals 0, since log of 1 equals 0. Wolfram alpha can get another solution numerically. Let's actually link this. About 0.9. About equal? About. By inspection, Stuki, exactly. That's why I don't like saying, or it feels like it's not as bad as obviously or clearly, but I feel like it's still kind of bad. In like a formal paper, I think it's fine, where there's an expectation that someone reading it knows math, but